Question number 1 was asking to describe how nitric acid can be prepared in the laboratory. That one, I want you to go to the notes and do it. Draw the diagram, and the substances to use are potassium nitrate and sulfuric acid, which must be concentrated. Part 2 was asking you to write the equation. And it is this on this note that I want to clarify this. If you check your answers, many of you, I gave you 1 mark and I denied you a half. A half which is meant for the states. I did not give it to you. And this is the reason. Concentrated sulfuric acid, which we are using here, is a dehydrating agent. It is hygroscopic, or it absorbs water. So, what is the state of sulfuric acid when it is concentrated, when it does not contain water, when it is not diluted with water? Its state is a liquid. Are you getting me? So, potassium nitrate is a solid, sulfuric acid is a liquid. Now, if you use potassium nitrate as a solid and sulfuric acid as a liquid, then there is nowhere where water is going to come from, because even if it is water from the atmosphere, it will be absorbed by sulfuric acid, which is hygroscopic or a dehydrating agent. So the states of the products, potassium hydrogen sulfate will be a solid, and nitric acid formed will be a gas. That is case number 1. So when you use sulfuric acid as a liquid, you cannot use aqueous for potassium hydrogen sulfate and aqueous for nitric acid. I think you are getting that point. However, if we use concentrated sulfuric acid, but which is diluted with some amount of water, if we use sulfuric acid which is diluted with some amount of water, then the state for potassium hydrogen sulfate is going to be aqueous, because you are using sulfuric acid which contains some water. So the state of potassium hydrogen sulfate is going to be aqueous, and likewise the state of nitric acid is also going to be aqueous. I think you have understood that the reason why states are like that. If there is any question, you can ask me immediately. Then these two reactions, we have seen it like 1,000 times. We have seen these reactions in like 1,000 times. Copper and nitric acid, moderately concentrated nitric acid. The product is copper 2 nitrate, but the gas is nitrogen monoxide, moderately concentrated nitric acid. And balancing, there is 8 on nitric acid, then 3 on copper, like that. However, when nitric acid is very concentrated, then the gas becomes nitrogen dioxide. So these are some of the important aspects that you should know as we go on. These are some of the important aspects about nitrogen dioxide that you need to know, and nitric acid, these two reactions. Then there was a question asking, it was part C, asking you to explain why a solution of ammonium sulfate in water is acidic. I told you, or I have told you many times, that when a question says explain, please write some words explaining, and also write an equation if it is there. If a question says explain, there will always be 1.5 marks for the equation. there will always be 1.5 marks for the equation. So how should you have explained that? Ammonium sulfate dissolves in water, forming ammonium hydroxide, which is a weak base, and sulfuric acid, which is a strong acid. Then you write the equation. This equation is 1.5 marks. Ammonium sulfate plus water. The products are ammonium hydroxide plus sulfuric acid. Then you balance by putting a 2 on ammonium to balance nitrogen. But what makes the solution acidic? I remember telling you the other time that when sulfuric acid is a strong acid, the definition of an acid, it is a substance that dissolves in water to form hydrogen ions as the only positively charged ions. So when sulfuric acid dissolves in water, it forms hydrogen ions and sulfate ions. So those hydrogen ions, since sulfuric acid is a strong acid, the hydrogen ions here are going to be more compared to the hydroxide ions, which are coming from a weak base. So a weak base is ammonium hydroxide, so for it does not ionize completely. So the hydroxide ions are few compared to hydrogen ions from sulfuric acid, which is a strong acid. So what happens? The hydrogen ions will neutralize the hydroxide ions from the base, which is a weak base, ammonium hydroxide, and the hydrogen ions will remain in the solution. And that's why the resultant solution is always acidic. So sulfuric acid ionizes completely and forms more hydrogen ions than hydroxide ions from ammonium hydroxide, which is a weak base. Is there anyone having a question on that part? It is important that you understand it, please. Derek, are you okay? Are you understanding the chemistry? Or you are just quiet? Okay. Then part D was asking you to state what is observed when potassium nitrate is heated. Potassium nitrate, they are white crystals, and when you heat them, they form potassium nitrate. This is potassium nitrate, and potassium nitrate is a pale yellow solid. So the observation, we should have said that white crystals turn, this should be turn, for correct English. White crystals turn to a pale yellow solid. And I'm saying the pale yellow solid is potassium nitrate, and the white crystals are, potassium nitrate, and the white crystals are for potassium nitrate. Then we had a calculation which was saying that 3.5 grams of potassium nitrate were heated. So we first get the RFM of potassium nitrate, which is 101. Then RFM is the mass of 1 mole, so that means 101 grams of potassium nitrate contain 1 mole. Then 3.5 grams, which we were given, they will contain 1 out of 101 times 3.5. So these are the moles of potassium what? Nitrate. So when we have the moles of potassium nitrate, we can now compare from the equation to get the moles of oxygen. And from the equation, it is clear that 2 moles of potassium nitrate forms 1 mole of oxygen. So if 2 moles of potassium nitrate form 1 mole of oxygen, then it means that the moles of potassium nitrate, which are 3.5 out of 0.1 moles of potassium nitrate produce 1/2 times these moles, which is a half times these moles. So we now have the moles of oxygen as these ones. But 1 mole of a gas occupies that volume, therefore these moles will occupy that volume. And when we use the calculator, this is the answer we get. Anyone having a question on that? This is your class, please feel free. Any question? So I will send you the correction together with the assignment after this interaction. So like I promised you, I sent you the notes. I think you all saw them. And I promised you that today shall be doing something new. We are going to start on another topic. We have finished 2 topics so far. So I'm telling those people who have been playing around, coming late, doing what, we have finished 2 topics. We started sulfur and its compounds, we finished it. We started nitrogen and its compounds, we finished it. So it's now up to you. Please read those notes, take notes, go through, understand. Where you don't understand, send me a message in my inbox. Now we are going to another topic. I told you page 244. Page 244. And what do we have there? We have chlorine and its compounds. So this is where we are. It's a new topic now. And I'm very sure the way you have been understanding the other ones, it is the same way you are going to understand this one. So chlorine and its compounds. Chlorine is a group 7 element, and you know that. So group 7 elements, they include fluorine as the first one, chlorine, bromine, iodine. But among these 4, in O level, you are only restricted to only study the chemistry of chlorine. The other 3, we are going to look at them in senior 6 and senior 5. And you had already promised me that you are all going to be with me in senior 5 and 6. So for chemistry, we shall look at them. So we are saying the elements include fluorine, bromine, iodine, and chlorine. They make up a family of related elements. The chemical family to which these elements belong, the group 7 elements, the chemical name given to them, they are called halogens. So halogens are group 7 elements. And the word halogen means salt producers. Preparation of chlorine. Like any gas, we first look at its preparation. Now listen to me carefully. Chlorine can be prepared by removal of hydrogen from hydrochloric acid, meaning the most important compound that is used in the preparation of chlorine is hydrochloric acid. So hydrochloric acid, from it we remove hydrogen and we shall form chlorine. From it we remove hydrogen and we form what? Chlorine. So the reaction by which chlorine is prepared, and removal of hydrogen, it also means removal of hydrogen, it also means oxidation. So the process by which chlorine is prepared is oxidation of hydrochloric acid. This can be done by one substance containing oxygen So we need one substance containing oxygen to oxidize hydrochloric acid to chlorine. The oxygen for the oxidation of hydrochloric acid is provided by any of the following. Now, any of these elements will help us to get chlorine, but the commonly used element is manganese 4 oxide. Manganese 4 oxide and potassium permanganate. So potassium permanganate or potassium manganate 7 is one of the oxidizing agents that are used to prepare chlorine. And by the way, at your level, I want you to only take note of these two. The other ones we shall again look at them in senior 5. So if I ask you the two substances which are reacted with hydrochloric acid to produce chlorine, one of them is potassium permanganate or potassium manganate 7, and the other one is manganese 4 oxide. Please. But these ones react with hydrochloric acid such that they can remove hydrogen from hydrochloric acid, which is oxidation, and you form chlorine. So preparation of chlorine from hydrochloric acid is done by oxidation with manganese 4 oxide. So we are now going to first use manganese 4 oxide, and the next one will be potassium permanganate or potassium manganate 7. These, please, when you write potassium permanganate, then you are not supposed to put this 7. But when you write potassium manganate, then you put what? 7. But don't write both. It is one name. When you write potassium permanganate, don't put 7. When you write potassium manganate, then put the 7. Preparation of chlorine from hydrochloric acid and manganese 4 oxide. Now, hydrochloric acid is going to be oxidized by manganese 4 oxide, as we are going to see. So place some manganese 4 oxide into a flask. Lamps are preferred to be used as the powder is very reactive. So lamps, we use manganese 4 oxide lamps, not powder. And because when you use the powder, the reaction will end very fast. So fit the apparatus as shown below. Pour concentrated hydrochloric acid down the thistle funnel. Then heat the mixture. Now listen carefully. When you use manganese 4 oxide, one of the conditions is that you must heat the mixture. When you use manganese 4 oxide, you must heat the mixture. And the acid should be concentrated hydrochloric acid. In preparation of chlorine, hydrochloric acid must always be concentrated. I repeat, in the preparation of chlorine, hydrochloric acid must always be concentrated. So this is the diagram. You know, concentrated hydrochloric acid is a liquid, so it must be put in the thistle funnel. Then manganese 4 oxide is a solid, so it must be put in a flask. And you see on my diagram, there is no tap. So this delivery cube must reach the lamps of manganese 4 oxide. Then the mixture should be heated. The mixture should be heated. Now, chlorine gas, when we are preparing it, just like carbon dioxide, since we are using hydrochloric acid, we must purify the chlorine gas by passing it through water. Why do we pass it through water? We pass it through water to remove the fumes of hydrogen chloride. So take note of that. Chlorine must be passed through what? Water. After passing it through water, then the next step should be drying. And chlorine gas is dried by concentrated sulfuric acid. It's dried by concentrated sulfuric what? Acid. And finally, chlorine gas is denser than air, so it is collected by downward delivery. So if I had asked you to describe with a diagram, this is what you have drawn, then you always have to write some words about your diagram, like how chlorine is collected and how it is dried. So observation, effervescence occurs. Now let us also keep in note, keep this in our mind. We can write this note in our books, that chlorine gas is greenish yellow. That is its characteristic color. We were saying that nitrogen dioxide is reddish brown, so we are now on chlorine. And we are also saying that chlorine gas is greenish yellow. That is its color. So a greenish yellow gas is evolved, which is chlorine. A greenish yellow gas is evolved, which is chlorine. And chlorine is evolved together with small amounts of hydrogen chloride. But we have already said that this hydrogen chloride is removed by passing the chlorine gas through a wash bottle containing water. Okay. The gas is then dried by concentrated sulfuric acid and is collected by downward delivery since it is denser than air. So nothing changes in preparation of gases. So here what you need to know is that chlorine is prepared. The substances that react together to form chlorine are manganese 4 oxide and concentrated hydrochloric acid. So I repeat, someone can ask you for the conditions for this reaction. Please, we are saying number one, the acid must be concentrated. And number two, you must heat the mixture. Okay? You must heat the mixture. Chlorine gas being poisonous, it is prepared in a fume cupboard. Now, that has been using manganese 4 oxide. Let us look at what happens when we use potassium permanganate. Remember, here someone can ask you a question when it is closed and it tells you the substances to use. You remember how you were messing up in preparation of sulfur dioxide? When I tell you to describe how chlorine is prepared using potassium permanganate, please don't use manganese 4 oxide. You are going to get 0. So both these two substances, they can be used to prepare chlorine, but we can ask you to use one of them. So use that one that we have talked about. So from potassium permanganate, the diagram is here. Nothing changes on the diagram. Now listen carefully. The only difference when we use potassium permanganate is that we don't heat. By the way, we didn't look at the equation. The equation is here. Manganese 4 oxide, this is its formula. Hydrochloric acid, we form manganese 2 chloride, it is here, plus water, then plus chlorine gas. There is a 4 on hydrochloric acid to balance. We first put that 4 to balance chlorine, because these are 2 and these are 2 also. So you form 2 they become 4 chlorine atoms. So you put a 4 on what? On chlorine, on hydrochloric acid. Now I was telling you the only difference between manganese 4 oxide and potassium permanganate, what changes is that when you use potassium permanganate, you don't heat. But when you use manganese 4 oxide, you must heat. So the conditions when you are using manganese 4 oxide is heat and concentrated hydrochloric acid. And the conditions when you use potassium permanganate, you should not heat and you should use concentrated hydrochloric acid. If the question is asking you to prepare a dry gas, please don't collect it over water. This delivery cube should be going to water to remove hydrogen chloride fumes. Then from water it goes to a drying agent of concentrated sulfuric acid, and finally you collect it by downward delivery. So if we had asked it to prepare a dry gas, this fume here, this delivery cube here, it should be going to the wash bottle containing water, and the rest stands as it is. Now listen. Drop on potassium permanganate concentrated hydrochloric acid from the tap, as shown. Now I want to tell you something. This equation is not easy to balance. I told you when an equation is not easy, I will always tell you. This equation is not easy to balance. What you should do is one, listen to me, put a 16 on hydrochloric acid. The products are, but this is potassium permanganate, and this equation is examined, it is under your syllabus of O level, so you must know it. If you fail to know it, cram it. If you fail to, but you must make sure that when we ask it in an exam, you can produce it. It is examinable to your level. Potassium permanganate plus hydrochloric acid. The products are potassium chloride plus water plus manganese chloride, manganese 2 chloride, then finally plus chlorine. I was telling you it is not easy to balance, but what you should do, remember that there is 16 on hydrochloric acid. And when you remember that there is 16 on hydrochloric acid, there must be 8 on water. 8 on water, you are balancing hydrogen now. The first ones are 16 and these ones are 8. So you put 8 on water to balance hydrogen to make them 16. When you put 8 on water, oxygen will become 8. Go to the left, they were 4. So you put 2 to balance oxygen to make them 8. This equation is not easy, but you must know. So put 16 on hydrochloric acid, then the work, you'll find it easy. The gas collection is downward delivery or over brine or hot water. Brine is concentrated sodium chloride solution. Brine is concentrated sodium chloride what? Solution, and it can be used to collect chlorine. But if the question is asking for a dry gas, then it should be passed through sulfuric acid concentrated and then collected by downward delivery. So this one, I don't encourage you to read it, this part. Only concentrate on the substances that I have told you. This one, don't bother. Concentrate on reaction preparation of chlorine using potassium permanganate and manganese 4 oxide. Those ones are the common examinable ones at your level. Okay? Yes. So now I want you to to take a short note on industrial manufacture of chlorine. Chlorine is manufactured on an industry by electrolysis, but unfortunately, we have not studied electrolysis. When we study electrolysis in senior 4, or we may study it in senior 3 because we are finishing these things very fast. That's when we shall look at electrolysis of concentrated solution of sodium chloride, and it is the one that produces what? Chlorine. So for now, allow me to skip this and we first study electrolysis, because I cannot teach you movement of ions now when you have not done what? When you have not studied electrolysis. So in industrial manufacture of chlorine, let us save it for the topic of electrolysis. Okay? Please, when you are writing notes or reading, don't bother yourself with that. Let us save it for electrolysis, the topic of electrolysis. So I want us now to look at physical properties of chlorine. Physical properties of chlorine, we have already said when we were starting that it is a greenish yellow gas. It is a greenish yellow gas and it has a choking smell or unpleasant or irritating smell. Many of you have ever taken water which has just been treated with water guard. You can even vomit. And water guard is majorly contains chlorine. One of the substances that are contained in water guard is chlorine. So that smell, that unpleasant smell that you feel almost like vomiting, that is chlorine. And chlorine is usually added to kill germs. So if you are not careful, it may end up killing you yourself. You may end up being a germ. So it has an unpleasant smell. It is slightly soluble in water. A greenish, yellowish chlorine water. So when chlorine gas is dissolved in water, the solution changes to yellowish. It forms a yellowish solution, and a yellowish solution is chlorine water. So when chlorine, this is very, very important. When chlorine gas is dissolved in water, it forms two substances. One of them is hydrochloric acid, and this is the formula of hydrochloric acid. And the other substance is hypochlorous acid. So a solution of chlorine in water is acidic because it contains hydrochloric acid. Please, this equation is very important. When chlorine is added to water, it forms two substances. One of them is hydrochloric acid, and the other one is hypochlorous acid. And this is the formula of hypochlorous what? Acid. So this hypochlorous acid is the one which is yellowish green. It is the one which is yellowish. So when chlorine is dissolved in water, a yellowish solution is formed, and the yellowish solution is hypochlorous acid. But hypochloric acid is colorless, so when they mix together, the solution still remains or appears yellowish. It is denser than air, and that's the reason why it was collected by downward delivery. It turns damp blue litmus paper to red and bleaches it. Like sulfur dioxide, the word to bleach, I told you, it means to lose color. So when a blue litmus paper is added to a solution of chlorine in water, a solution of chlorine contains hydrochloric acid and hypochlorous acid. So hydrochloric acid being acidic, it will turn the blue litmus paper to red. Then hypochlorous acid is the one that is responsible for bleaching the litmus paper. So the blue litmus paper will turn to red, and finally it will turn to white. It will lose its color and turns to what? To white, it becomes bleaching. So its bleaching action is due to the formation of hypochlorous acid. So hypochlorous acid is the one that is responsible for bleaching the red litmus paper, which has turned from blue. And hydrochloric acid is the one that is responsible for turning the blue litmus paper to red. But dry chlorine does not bleach because it is not dissolved in water, so it will not form hypochlorous acid, which bleaches. And the test for chlorine, it is a greenish yellow gas which turns moist blue litmus paper red and bleaches it. That's how chlorine works. It turns moist blue litmus paper to red and bleaches it. We shall stop there for chlorine for today. If there is any question, I'm seeing time is chasing us, I will request you to send it to my inbox.